For months now, China has been sending nearly wartime numbers of flights into the Taiwanese identification zone, and sometimes over Taiwan itself. Since September of 2020, China has sent over 800 flights on military aircraft to Taiwanese airspace, sometimes with over 50 planes in a single sortie. Each time the Taiwanese Air Force is required to respond to such flights or face an increase in boldness on the part of China. Despite the tensions and the massive resources invested, no weapons have been used, and nothing conclusive has resulted in these activities. So why are these flights being conducted? What does China have to gain despite no progress on an invasion? The investment is huge. The flights being conducted on the part of China are extremely expensive, hence why you don't typically see these operations conducted on such a scale outside of large military exercises. Each plane is a massive asset, but with such a strategic advantage comes with it a massive investment in resources. The cost of operating each plane is calculated differently depending on certain parameters. For example, the cost of the hourly operation of the F-22 and F-35 includes things such as building hangars and logistical concerns, whereas the hourly estimates of the F-15 and F-16 do not. While the operating costs of the 5th generation fighters are higher than that of 4th generation fighters, the extent of which is disproportionately represented. So while estimating the hourly cost of China's aircraft is difficult for a multitude of reasons, including lack of release data, we can assume a ballpark similar to other countries operating airframes with somewhat comparable avionics suites. Unfortunately, when using such methods, it's still difficult to compare, as 4th generation fighters have a massive range of operating cost, even when taking into account the different methods of calculating such numbers. From $4,700 an hour reported for the JAS-39 to the 20,000 pounds an hour reported for the Eurofighter Typhoon, it can be very difficult to calculate a reasonable number. Suffice it to say, however, the number of flights is exceedingly pricey, as the more hours you put on an airframe means the more parts that eventually have to be replaced. When it comes to aviation, a lot of people are shocked at the amount of maintenance an aircraft receives. The truth is, the vast majority of the maintenance is preventative in nature, not reactive. It's not spent on fixing the aircraft. The time is spent inspecting the aircraft, ordering parts ahead of time. So by ramping up the number of flights on an aircraft, you increase the number of required inspections the aircraft needs to receive, even if nothing breaks. Naturally, as the use of the aircraft increases, the rate of wear and tear increases, and so too the number of replacement parts that need to be produced in production. And none of this even factors in the obvious like fuel, paying for the pilots and maintenance crews, and the huge feat of organizing such huge events. It should also be mentioned everything said about the investments of China is also just as true for the Taiwanese Air Force. Every time they launch their fighter aircraft, they are burning through finite amount of time the airframe can fly with structural integrity. Even with insane amounts of maintenance that goes into these aircraft, the structural integrity can only be guaranteed for a finite number of hours. So along with the massive spike in maintenance requirements, consuming resources and manpower, you are also cashing in on the lifespan of the plane to defend your home country. However, this is the least damaging in regards to these operations. What is there to gain? The major reason for China performing these massive flights, sometimes with more than 50 planes in a single sortie, is it forces a response from the Taiwanese government. In order to defend themselves, air defenses are required. The heart of all air defenses is a radar system. In order to track the Chinese aircraft, they use radar. But radar is a dual-edged sword. In order to illuminate the target of interest, a radar signal has to be sent to the target, and then returned to the source. Not only that, but because the signal intensity degrades significantly over distance, the transmitting radar needs to input a lot of power in order for the signal to reach the target, and return to the antenna at an intensity higher than that of background noise. This means that an aircraft can detect those radar emissions far sooner than any radar sending those emissions can see them. If an aircraft has specialized equipment on board, it can intercept those radar signals and record them for further analysis. With enough data, you can use triangulation to determine the location of the radar system emitting the radiation. This is important as missile defenses are often rotated between different locations for this exact reason. With further flights, you can determine the rotation schedule and know when and where they should be. With even further analysis, you can even determine the specific characteristics of a specific radar system and create a profile for it. This means you can know what specific defense system is tracking you and decide how to engage it based on its capabilities outside of the detection range of the threat itself. For this reason, it's best to keep radars off until it becomes time to use them. The US, for example, will send F-22s with fuel tanks and with their radars turned off to intercept targets of interest. And this way their radar cross-section cannot be scanned, and their radar profiles cannot be determined. With the newer batch of F-16s in Taiwan using AESA radars, this is even more important compared to the older F-16s using passive arrays. AESA radars can scan specific portions of the field of view in patterns, reducing the time spent in exposing itself to the target, and increasing range due to the increased gain. In addition, they can frequency hop to a certain degree, further encrypting and decreasing probability of detection. It is in China's interest to coax these defenses into feeling threatened enough to use their radar systems in order to build profiles that planes can essentially listen for with their radar warning systems. Finally, another reason this is far more insidious than it seems on the surface is the fatigue of personnel tasked with defending the country. The worry of impending invasion, coupled with the complex task of defense, means that people are likely to get worn out. For this reason, shift changes are conducted, as you would expect. However, the response times can be measured, meaning any deviation may indicate a shift change, and a small window of degraded service has then been measured. Why it's scary. Russia conducts these flights extremely routinely, yet it's rarely a cause for concern, barring a pilot flying recklessly. What makes these flights so scary, however, is the announced timetable from China that they want to bring Taiwan into their control, and the fact that the intelligence gathered from these flights has a relatively short shelf life. This, combined with the massive expense, implies that China seeks to deploy its forces sooner rather than later. Possibly they seek to bring in Taiwan as they see the growing amount of support the country has been gaining worldwide. The United States has not been consistent in its support of Taiwan until recently, where support has been increasing inconsistently but surely. For that reason, it's in the best interest of the Chinese Communist Party to bring Taiwan under control before the United States fully commits itself. Thank you for watching. This channel aims to provide complex information in a way that's easily digestible to the common viewer. If you like this sort of content, then please subscribe. Until the next video, enjoy your dance with the angels.